Hello there. Today we'll be starting our backtracking problems, number 71. We're going to get to 75 very soon. Very good problem, subsets. It's to get us started thinking about how to do subsets, which basically means that we'll be getting and backtracking, which means we're basically getting every single item, every single possibility. What does that mean? That means every possibility here. What does every possibility here? So every possibility means we start with a 1 or not a 1. And then we either get, so there's 1 or nothing. Then we look at the 2 and we either say, oh, we want the 2, or we don't want the 2. We want the 2, we don't want the 2. Then we do the 3, we want the 3. We don't want the 3. We want the 3, we don't want the 3. We want the 3, we don't want the 3. We want the 3, we don't want the 3. So, and that's how we get all the possibilities, all 8 possibilities here, as you can see. And that's how, so using this, going from here to getting the answer, how do we code this up? Well, it's about getting something or not getting something. And what is this end state? The end state is that we have went through all the indices, and we have gone to a point where we have built up to the end of the indices, and we've chosen to not get anything, or just get this one, or just get that one. So that means we need a result equals empty, and we need subsets equals empty. Then we define the DFS because we need to go through all the indices, and we need to repeat going into the indices. I think there's a lot more to learn here. This is our first problem, so let's learn this much, and we'll learn more next time. So here we're going to have a if I is greater than the nums, lang nums, and if that is greater than or equal to lang nums, it's just, why don't we just say equal to? I mean, I get the this is a very we do this all the time, but it doesn't make any sense. So we're returning because we can't do anything about it. So resolution, result is gonna dot append. What we're gonna do, the subset dot copy, because that's a deep copy, and that's how you get one in Python. And just let's use the language, right? And so here we want to say let's get it, skip it. So how do we get it, right? So to get it, subset dot append nums at I. Then we run DFS at I plus 1. So by running the append, that means we get it and we move on. We get the item, we move on. And then we subset dot like pop, that means we skip it and we move on, right? And with these two items, we will be finished with our problem, and we can return the result. And some of you might be wondering, why does this work, and what is the time complexity? The time complexity is 2 to the n, as you can see here. So 3 items, 2 to the n, so 8. And the multiplied by the subset.copy, which will take O of n time apparently. To make a copy, that's just the way how long it takes. So n times 2 of n, 2 to the n. Okay, next problem. I don't know. I don't see why it can't be done in O1. It makes no sense to me. Anyways, next thing. How does this work? Why does this work? Well, think about it this way. Let's append everything, and then this becomes like I equals 3. Well, we got our first item, 3. Then we pop it, and then we get our second item, right? And then we pop that, and we add the 3 in. So yeah, we pop it, right? We go back into here, well, I plus 1, and look, we can append the 3. Let's append the 3, and then we do DFS I plus 1 again. We maxed out. We're done. We go back and we pop again, and then we plus 1. We get the 1, and then of course we pop that, and then we end up with 2, 3, and 2, 3, and then no items, right? So that's how it works. So let's submit. All right, very good. It's working. So at this point, I think we have learned enough about subsets. It's about picking one item and not picking an item, and this is how we do that, and going through all the items. I think there are better methods, which we'll learn later as we do more and more problems. But with this particular problem down, let's go learn some more at the next problem. Thank you very much, and I'll see you in the next one.